I almost started writing on my tablet with the regular pencil. Okay, if you guys didn't get a chance to look at the weekly calendar, I'll kind of give you the outline of the week. So today we're doing 7-8, which is actually kind of like our last normal section. 7-9 that we're doing tomorrow, you'll see it's not new. And the way I'm going to approach teaching you 7-9, it's not going to be anything different, to be honest. So, but then that's the end of our chapter. And so we're going to be doing our review on Thursday. I know it's weird, today's Tuesday. So we're going to be doing our review on Thursday. And for those of you who haven't done the concept checks, Thursday is when those should be done by. And then Friday is supposed to be our test. But so Fridays now are the flex schedule, I believe. I'll find out. I think this Friday is a Monday through Thursday schedule, because if I think this Friday is an A day, and so in that case the class would be 75 minutes long. If it's a flex Friday, then class is only 45 minutes long. But I'm pretty sure because this is a shortened week, Friday is like a Monday through Thursday day. So in that case, I'll have you guys take the test during the class hour. If it's a shortened hour, like regular Fridays, then I'll have you guys take the test in the afternoon. But I'll find that out ahead of time. I'm pretty sure it's like a Monday through Thursday day because it's a shortened week. But otherwise, that's our plan for the week. So 7-8, the last regular section, is on multiplying things out. And for a lot of you, you kind of have a handle of this already, but this just basically, puts a lot of things together. So the beginning of 7-8. This would be like example number 1. We've got 5x squared times 4x cubed. The way I approach this is these both are considered one term, monomials, because there's no plus or minus signs. So when I'm looking at this is like one big multiplication thing. This is like 5 times x squared times 4 times x cubed. And so since everything is being multiplied, those parentheses, they don't really do anything, right? So if it makes it feel easier for you, you don't need to write them. If those parentheses don't bother you, you don't need to rewrite this. Like it's just kind of personal preference. But then as I'm viewing it, 5 of the x squareds times 4 of the x cubes, I'm going to do the two numbers together. Here, let me try to color code this. Come on, there we go. So I'm going to do the 5 times the 4 first. And then I'm going to do the x squared times x cubed next. Now it's still all one answer because I just basically rearrange things. But I group them together so that I could combine things. So like 5 times 4, is 20. X squared times x cubed. Murph, do you remember what we do when we're multiplying x squared times x cubed? What does it become? Okay, we basically have two choices. So you're either going to add the powers or you're going to multiply the powers. That's what most people kind of break it down into. Does anybody remember? Just kind of leaving it open for whoever. Does anybody remember what we do with these powers when they're being multiplied? Like the bases are being multiplied. Or did this double 4-day weekends in a row basically make you guys forget everything? I wonder if that's a possibility. So if we have x squared times x cubed, we're going to add their powers together. So 2 plus 3. So you'd have 20x to the 5th. Maybe I should get kind of an idea from you guys how much of this stuff you forgot, to give me an idea how fast to go through today. If you guys could kind of put in the chat a 1 through 5, or a 0 through 5, I mean, like how well do you feel you remember this multiplying? That'll kind of give me a clue as to how fast we should go through today, or how much I should refresh you. Because I totally get that 4-day weekends, 4 days doesn't sound like a lot, but if you're not doing math every day, it is a long time. Okay? Okay. So I'll go semi-slow for you guys. I don't want to fly through it then. So here's the next one. And it's basically got 3 things being multiplied. Ben, what would you do first? Can you kind of guide me? You know what? I'll scroll back up so you can see the other one if you need to. There you go. What would you do first on this blue one? Okay, what does that mean to you? I mean, like, what you're saying is good, but... Or were you just trying to kind of answer something? No, that's all right. Okay, so on this pink one up above, when I was multiplying 5x squared and 4x cubed, the first thing I did was multiply the numbers together. So when I'm looking at this one, I'll start with that. And that's a 2. That's just my bad handwriting. So what do I get if I multiply those together? Yep. Yep. Perfect. Okay. So that's how we would start. Then here's where I was, when you said do like terms, this is what I thought you were trying to say at first. Then I'm going to go and multiply all of the x's together. And the third one doesn't have one. So I've got x cubed times x to the first. What would I get if I multiply x cubed times x to the first? And you can answer it if you want. Otherwise, if you want to call somebody else, you can. It's up to you. Oh, pick somebody then. Okay, perfect. Thank you. Logan, do you think you could remind me what power would go on the x if I multiply x cubed and x to the first? Yep. Yep. Perfect. Perfect. X to the fourth. So off on the left here, maybe I'll put this over here because I think maybe some of you might need to see it. If you have same bases being multiplied, you add their powers together. And that's kind of the case we have right here. If you have a power to a power, then you multiply their powers. That's kind of what we were doing the previous sections. So if you need to kind of write this for yourself, you know, that's not a bad plan. And then I'm just going to kind of go in order through the rest of this problem. So we did the x's first, then we'll get to the y's. So I have a y squared here. The middle one doesn't have a y. The third one does have a y. So, Sophie, what would I put for the y's in the final answer? Perfect. Perfect. This regular y is y to the first. So we're going to see a lot of those. And that's kind of why I made sure to put it in this example. And then we only have one letter left. And I've got z to the fifth and z to the first. So that would make z to the sixth. Go ahead, Ben. Did you have a question? What the heck? I'm actually getting texts. Or did you just forget to mute? That's all right. Okay, this one I wrote in blue is probably going to be considered the most difficult style of monomials. The only other thing that can be done to it, oh, not this next one, is maybe there might be a parentheses with a power on one of them. But otherwise, this is about the most difficult style because it's got all sorts of things going on. This second example, Gracie, what's different about this green one? Do you kind of see what's different about this green one? Oh, okay, that's perfect. That's a good way to say it. The item that's different is the fact that we have plus and minus signs. So then that's going to make terms. As soon as you have more than one term, you have to approach it differently. Like if we have a bunch of monomials, you just multiply everything together. But once you have terms, you're going to have to distribute, that was a great way to say it. So like this 5 that's in front of 3 different terms, I'm going to have to multiply each one of the 3 terms by a 5. And that's the main difference between the style questions. Oops. So 5 times 2x squared would give you 10x squared. 5 times x would be 5x. And then the plus and minus signs generally stay the same unless you're multiplying by a negative symbol. So plus 5 times x, which is 5x, plus 5 times 4, which is 20. Let's see, John. So just as a reminder, since you just got here, the school has the new schedule this week. So we start at 10 o'clock. And that'll be for the rest of the semester. Yeah, no, that's no problem. I figured I'd just make sure to let you know I knew there'd be some people coming in today at 10:15, just out of habit. So I'd like you guys to try the blue one on your own, okay? You're going to take 2x squared in the front and multiply it times each one of these 3 separately. So your final answer will be 3 separate things, 2x squared y times each one of them. Why don't you guys see if you can kind of do that one? Oh, also, is there anybody in here whose third-hour teacher didn't tell them the lunch schedule yet? Like, does anybody not know if you're supposed to? Basically, the only lunch that probably matters is a lunch, because if your teacher has a lunch, that would be lunch before class. If your teacher has B, C, or D, I think there's 4 lunches now. If they have B, C, or D lunch, then it's like split lunch, basically. Is there anybody who needs? Okay, so AJ. So I need. I'll get it open here first, and then I'll just need to know your teacher for. There we go, lunch schedule. Who's your teacher for? Oh, geez. Bunch of people. How about this? I'll just read off the teachers for each one of the lunches. I don't have my bifocals. I feel old. Okay, if your teacher this is the teachers that have a lunch, and so that'll matter because your lunch is going to be directly after this class. If you have Bachman, Bailey, Bidwell, Caponegri, Carly, Shampoo, Frisco, Grawl, Hansen, Horton, Hostiger, Karasek, Laux, me, which you wouldn't, Meyer, Noyes, Taylor, W. Taylor. Oh, that's the math teachers. No, you don't have them. Thompson, Tolis, Ware, and Winston. So those are the 8 A-lunch teachers. So that lunch will be directly after this class, and then your actual class would start at 12:10. Here's B-lunch teachers. Banderskish, Barry, Filipowski, Flynn, Fritzy, Hildal, Larson, Malat, Newton, Pape, Parker, Ramey, Salinas, Schrank, Sullivan, Valenta, and Young, the German teacher. So they have B lunch, so you'll go to class, split lunch, come back to class. And these are the C lunch teachers. So I guess there's only 3 lunches right now. So you will have class first and then lunch after class. Allen, Borseth, Brem, Brookins, Den, Ekman, Gavin, Gretz, Gulick, Haley, Hammernick, Harberts, Herrera, Howard, Young, the science teacher, Kenley, Moore, Nagahashi, Ulrich, Ramsey, Rekstad, Sprout, L. Taylor, Westfall, and Werman. Okay, after reading that, is there anybody who's still not sure? I figured you might need that because if you have a 9th grade teacher, they might not have even thought to read it off to you. And I probably screwed up your plan on trying to work on that problem possibly too. So if I'm taking 2x squared y times 3x, the 2 times the 3 is what I would do first in my head, 6. Then I would approach x squared times x to the first, and get x cubed. And then I would take the y times other y's, but in this case there isn't another one, so then it would just kind of stay as is. Minus sign was here. There still would be a minus sign because there was nothing to change that. And then I'm basically only taking a single y times 2x squared y. So the only thing that's going to change is my y to the first times y to the first would make y squared. So I'm going to have 2x squared y squared. And it looks like I need to make a little bit more room. And then I'm going to take 2x squared y times 2z. The plus sign stays the same. So the 2 times the 2, 4. X squared, there's no other x's, so it stays x squared. Y, there's no other y's, so it stays a y. And then this z here still gets multiplied, it's just nothing to combine it with. So the final answer definitely looks complicated, but we didn't do much during the problem. And that's how a lot of these are going to be set up. And in fact, after a while, we stop using multiple letters, and so for a lot of you, it will feel easier. Anybody want me to answer any questions from either one of the green and blue one? Like maybe there was part of that you had trouble following. Okay. Then let's move on to the next level. So this is when we're going to take binomials times binomials. A binomial means I've got 2 terms. So I'm going to take 2 terms times 2 terms. And what happens is you get 4 answers, right? So you get 4 terms. And I'll give you a minute to write this down. Especially for you to write FOIL. So if you've seen this before, FOIL is an acronym to kind of guide you how to multiply it out. And for some of you, FOIL makes it harder. For some of you, FOIL makes it a lot easier. I'm just going to teach you both ways. But FOIL is important to know because you're generally going to hear somebody talk about foiling, whether you actually use it or not. If somebody mentions FOIL, they're telling you to do binomial times binomial. Okay, I'm going to try to color code it for you. We'll see how that goes. So the FOIL acronym is to tell you kind of an order on how to multiply. The firsts is going to be the first item in each parentheses. So x times x, which would be x squared. So this is the firsts. The outsides, if you look at this as complete order 1, 2, 3, 4 things, the outsides would be the first one and the last one, like the x and the 2. So x times 2 would be 2x, positive 2x. This would be the outsides. The insides, let's see what color, let's go with orange, sure. The insides is, well, the opposite of the outsides. The 2 numbers that are on the inside of everything. So 3 times x. And then the lasts, well, would be the 2 last in each parentheses. And so in this case, 3 times 2. So the 2 things times 2 things gives us 4 things. And it doesn't matter, order you write them out. Most people do it in order from power down. That's like standard form. Alex, what do you notice about these 2? Can we do anything with those? Perfect. And that's going to happen a lot of times. It doesn't have to, but you'll notice that these 2 middle ones often will go together. So your final answer, plus 2 plus 3, would be this. So this is what foil is. The only reason I really want you to know the foil acronyms is you definitely will hear it a lot. Okay, so if you ever hear FOIL, that's somebody just trying to tell you that you're going to do a binomial times binomial, because the FOIL is the acronym to tell you the order to multiply them. Now, I'm sure some of you, that'll help a lot. I also bet some of you this makes it feel more confusing. So here's how you do it without FOIL. And I don't have a preference. However you like to do your work, you can do it. I just care that you show your work, whichever way you're approaching things, right? So here's how to do it I shouldn't say normally. So I think it was Gracie on the last problem who talked about distribution. It's the same thing on this problem. So you're going to take this first x and multiply it times everything in the other parentheses. And then you're going to take this 3 and multiply it times everything in the other parentheses. So that's distribution. Now what you'll notice is it's the exact same thing as FOIL. X times x, then x times 2, so that's the outsides, then 3 times x, which is the insides, then 3 times 2. So some people, it's flat out easier for them to think about this as distribution. Some people, the distribution confuses them, so that's what FOIL is for. I want to make sure you know what this represents and everything so that you can get on with any question you have. Why don't you guys try this one in blue? See if you can figure out the answer for the one in blue. And you can either use the FOIL method or distribution. Yeah, AJ, wait, are you talking about the notes or the lunch schedule? I think so. If I remember right, this prints out really weird. I'll try to figure out how to save the notes for you. I mean, like, I know I have the notes saved. I'll try to figure out how to print them out. Why don't you send me an email so I can just email it back to you? Yep. See, Sadie, do you think you are ready to guide me on this one in blue? How did it go for you? Or do you want me to kind of help you through this one? You there, Sadie? Isabella. Do you think you can guide me through this one? Okay, perfect, thank you. Or otherwise I can help you out if you want help too. Okay, good start, good start. Okay, good. Perfect. Nice job. Oh, nice. How did the blue one go for everybody? Maybe I should ask that. Because this one is going to be really important for chapter 8. Yeah, if you guys could put 0 to 5 for the blue one, yeah, I mean, good is fine too. So they'd be pretty curious to me to know, because this is going to be really important for the upcoming chapter. And if multiplying this out went okay, then that's a great start. Not much left. I'm not even sure I'll do the green one, but although what time do we go till now? We go till 11:15. So what do we have? Okay. I wanted to kind of still stay with my, approach of giving you about half the hour to work. I'm not sure if we'll do that when we go back to the classroom, but we'll see. Who have I called on? Haroon. Haroon, this purple one, do you remember what the squared means? So I'll tell you to start with that we cannot do that. That's going to be the mistakes, a lot of people will make. Haroon, do you remember what this squared means? How about Desmond? No, you don't actually. That's why I wanted to put this one up. So if the problem was written as a monomial, like 5x, if it's a monomial, then you can square each thing. But if you have a plus or minus sign and have more than one term, you can't just square each one. What you're going to do is squared means that you're multiplying something times itself. So I'm going to write it out the long way. And if I write it out the long way, well, then I can see that I've got to do foiling or distribution. I'm going to do x times x. I'm going to do x times 5, that would be the outsides. And then I'm going to do the insides, 5 times the x, same thing. And then the lasts are going to be 5 times 5. So I get x squared plus 10x plus 25. And it absolutely seems like you should want to just square each thing, because that's what we had been doing. And I get why it would feel confusing. So you can only do that if it's a monomial. As soon as you have pluses and minus signs, you can't do that. I don't know. I don't know if we need to do the green one together. I guess I'd almost prefer to go right to the last problem because it takes a little bit of time. Maybe what I'll do, I'll just write the answer for the green one. And so if you guys want to copy it down, you can. It's not any different than the one in purple, it just goes slower. It goes slower because there's more than one variable. I wanted to get to the last one, which is more annoying than anything. It's not because of difficulty, it's just annoying. And it looks harmless, right? So we just talked about how squared means times itself. Well, cubed means times itself 3 times. So if I write that out the long way, the real issue is you can only do 2 things at a time. You can't multiply all 3 things at the same time. So you're either going to choose the first 2 or the last 2. But you can only do 2 of them at a time. I mean, you could theoretically choose the first and the third, but that'd be weird. It'd be be more complicated than needed. So you can only multiply 2 things at a time. I'll multiply the last 2. And so you would FOIL them out. And I'll tell you what you get. I'll just give you the answer. But you'll notice that I put the answer to that in its own parentheses, because I'm still multiplying by something else. And now you can absolutely see why these are slow. So now I have to do distribution. I can't say FOIL, because FOIL only works when you have 2 things times 2 things. Now I've got 2 things times 3 things, which give me 6 things. So you have to do distribution even if you didn't like that method before. So I'm going to take the x. I'm going to multiply it times all 3 things. I'll try to color code it so you can follow it. So x times x squared would be x cubed. X times minus 4x would be minus 4x squared. X times plus 4 would be plus 4x. And then I'm going to take the negative 2 times everything. Negative 2 times x squared. Negative 2 times negative 4x would be plus 8x. And then negative 2 times 4. So we end up with 6 things. And then your final answer, you're going to combine anything that goes together. So like x cubed, I go through and I look, there's no other x cubes. Okay? X squared, there's one other x squared. So minus 4 minus 2. And then I get to the x's. Plus 4x plus 8x. And then I get to the regular numbers, and that's the only regular number. These aren't horrible. They're just super slow. And then the other portion of them that makes them difficult. There's a lot of places for you to make a mistake. So if we get one of these questions on the test, what I usually do is, like, say, it'll be worth more points, like 5 points or something. And I would look to see, like, where you made a mistake. Like, if you made a mistake at the beginning and that was your only mistake, your answer's obviously going to be wrong, but I wouldn't take many points off because you would have made just one mistake kind of at the beginning. So these are pretty slow to grade as well, but just because they have a lot of steps. Okay. This is definitely a big section. It's got a lot of parts to it. The homework is broken up again into 4 different things, so that each type of homework question you have is a separate assignment. And you guys are welcome to kind of set it up however you want. But the homework is broken up into types of problems. And that's kind of how I did my notes. Like 7.8.1 is your first assignment. 7.8.2 is your second assignment. 0.3 third and 0.4 fourth. So that's how I tried to break up the notes.